Tranquility Base here. The Eagle has landed.
Since I missed your stream for IFT5, take this.
Okay. All right, I'm here. All right, welcome to the Space Nerd, EJ the Space Nerd, EJ the Space, I don't know, whatever. Launch coverage of Falcon Heavy, SpaceX NASA Falcon Heavy Europa Clipper launch. Big deal. Big deal. This is a mission that's going to explore Europa. It's being launched on a Falcon Heavy out of Cape Canaveral, or no, not Cape Canaveral. It is Cape Canaveral. Kennedy Space Center on at Complex 39A. I'm still waking up. I'm EJ. And yeah, I'll be taking you along on this fantastic voyage.
Incredible.
Let's tune into the NASA stream. Let's see what's up.
And when I was struggling with this incredible prompt, in this incredible ask, I realized that it's not just a poem that's going to Europa, not just a poem that's on the Europa Clipper, but a poem that's for us. It's a poem for everyone here on Earth. And that was really important to me as I tried to... to choose the right imagery and the right language.
Not a tough ask at all.
No, not at all.
What is happening?
And not
here?
only that, but we're taking your poem with us. So we have here a replica of the vault plate. This is the plate that's going, that is part of our vault on the spacecraft that's protecting all the sensitive electronics from all that radiation.
poem?
And it's written in your own handwriting.
Yeah.
How does it feel knowing that a piece of you is going to Europa?
You know, one of the things that I keep focusing on is that it really is a poem for all of us. But when they asked me to do it in my own handwriting, my grandmother, who passed away a year ago, she was the one who taught me to really make my handwriting as perfect as could be. And every time I look at this piece, I feel like my grandmother is part of this project too.
I heard you had to rewrite it a few times to get it just
You
right.
think? Yes, many times.
The handwriting is as beautiful as the poem itself, I assure you.
Thank you.
And what do you hope people take away from this?
You know, I really hope that as we embark on this incredible voyage together, that we are reminded of the wonders all around us, that it's not just in these huge moments of exploration that wonders exist, but that they are everywhere around us all the time. And we can't be lonely if we are all connected to this universe.
Well put. Thank you so much. And I mean, one other note that I want to point out is, Jenny has always talked about this, that mix between science and art. I mean, really, there is a connection that we should be talking about.
Yeah, I think that it's so important. In fact, we do ourselves a disservice when we separate arts and science because we're connected by curiosity and wonder.
Perfect. You are so well spoken. I see why you're the U.S. Poet Laureate. Ada, thank you so much for being here. We really appreciate it. And thank you for the beautiful piece of poetry you gave us for this mission.
Thank you. Thank you. It's been the honor of my life.
Thank you. Thank you so much. If you are
I don't talk about
inspired,
losers,
really, as Ada was, to write about our universe, and you want to write your own poetry, the QR code on your
Okay, yeah, I'll write poetry. Okay. Yeah. Brandon, congrats on over 2K. Whoa, we got over 2K? 2,000 subscribers on YouTube's? Holy crap. The YouTube's bussin', man. Thank you, guys. I appreciate it. I mean, we could write a poem about it. I'm sorry, was that too mean? Was that too... Okay. You're right. I need more coffee. Sorry, the New England came out there for a second. Nah, I'll put it back in. Bro, I you know what, Sidestep? Ironically, I appreciate the penmanship. Writing legibly, lost art. Pet peeve of mine. Straight up. I actually appreciate that part. How about no? Scott. Yup, up. Andrew, the subscribers are leaving. Jeez. That's the artifacting is actually not me. That's not me. That's their stream. Can you show the handwriting again? Yeah, we're 10:45 out till Europa Clipper here. Let's we can back up a little bit. They really didn't, because they're only broadcasting in 720p. That's beautiful. It's beautiful penmanship. Like actually, I appreciate that. That part I'm cool with. That's beautiful. Yeah, that part's impressive. Anyway,
There's water underneath the ice. When you think
guys,
about
we're gonna run
water,
ads
I mean, there's
so
quite a
nobody
big
gets
craters, right? And so
uninterrupted
we talk about so
covered
many
boats.
bodies in the solar system are that way as well. But Europa's surface is really different. There are some craters, but not very many, and that tells
All right.
us that as a
I'm gonna run the ads
young
so nobody
surface
gets
that's
pre-roll during the
geologically
launch.
speaking, and that begs the question of why. So
Right.
that was one of the avenues to scientific questioning that we had that led us to believe that there is water underneath the ice.
right? So we know about Europa. Well, it is Jupiter's fourth largest moon and only slightly larger than our moon. It's really
Brandon,
cool.
fast forward. I'll start the poem. There once was a streamer from Boston who didn't like how much it cost him. Yeah! All right. Lazy Drifter gifted a tier 1 sub to Tupra. All right. Thank you.
fast.
Yeah. All right, and let's take a look at the launch countdown again. We are now 9
Poetry
minutes
tip
and
$5.
counting until Europa Clipper
Oh, hold
launches.
up.
No issues to speak right now. The weather conditions are
I gotta play that one.
Their screen right there. Jenny, how are you?
And Hokie, thank you very much.
I
Man.
am just absolutely
Yeah,
buzzing.
Swifton, Tranquility Base here. The Eagle has landed.
Just so
Roses are red,
excited to get
violets
Clipper
are
up
blue.
into space
Can
where
the
it
Boston
belongs.
drink your coffee and let's cover space stuff? Also something that rhymes with blue.
And really the scientific community.
You should be a poet.
Absolutely. So astrobiology is kind of the study of how, life is distributed around.
All right, so this is the Europa Clipper mission. Falcon Heavy here is poised at the pad at 39A, Kennedy Space Center, and they're going to launch the Europa Clipper mission to the moon, Europa. My brain just stopped working. I'm not gonna lie. I need more coffee. All right, so Europa is a icy moon it's out near Jupiter, if I'm remembering right. My brain is still not working, just to be absolutely sure. That's not me, by the way. The artifacting on the stream, that is awful. It's going to take 5 years to get there, and it's going to explore Europa. Europa could have a lot of water. Could have a lot of water ice on it. I mean, we know it does, but the NASA Twitch is better. Okay, is this NASA Plus? No, this is the YouTube thing. Yeah, we should probably switch. Is it doing any gravity assists? It's not a direct transfer. No, it is doing multiple gravity assists.
California also on console for their spacecraft, just shifted their spacecraft to internal power.
Yeah, they started transitioning everything to internal power. We'll get full confirmation of that in about 2 minutes.
They're clipping Europa.
Things are good to go, and things are looking good on the preparations for the spacecraft as we move forward.
Engine chill has started.
Oh, nice.
There we hear the call for booster engine chill started on the 27 Merlin engines, getting ready for a liftoff at 12:06 p.m. today.
Mm-hmm.
T-minus 6 minutes and 45 seconds and counting for liftoff of SpaceX's Falcon Heavy rocket with NASA's Europa Clipper spacecraft. At the very top, it is a beautiful day here in Florida for launching a rocket.
NYRP1 load is complete.
As we wrap up loading the RP1 in the first stage boosters, we've just seen all three go completely filled.
I don't know the
Now
ground
we
track
await
on
for
this one,
all
Flava.
three of the LOX tanks inside the first stage booster to get to their
I
full
think the
point.
track
You
is
can tell they're
straight
most of the
east,
way
but I'm
there.
not
As you look
sure.
on your screen there, you see the
I want to try and watch it from the Florida
cold,
coast.
icy
Dude,
cold rocket
if you're on Florida's
condensing
east
that
coast, you should
Florida
be able
air.
to see it no matter where it goes.
Yeah, the team is continuing to load second stage. Also
How much
with
damage
LOX,
does a
so
rocket
we're
do to
getting
the
very close.
atmosphere?
We can see on the telemetry here
Minimal.
that the LOX
It's a
load with
minimal
the three
amount. It's no
boosters
more
is
than
getting
flying
near
a plane
completion.
around.
The team is continuing
Actually,
to
it's
follow
probably
the
a
procedures
little more than
and,
that.
Look at the
But we
vehicle,
don't
make
we don't
sure that
launch
we are
them
good to go for a launch
nearly
at
as much as
12:06,
like planes
but,
take off,
things
for
are
instance.
progressing
So it's
per
not as
procedure,
bad as
Daryl,
you might
and
think.
all is looking good for a great launch. With this
Personally,
beautiful
negligible
weather,
amount
launch
for
complex 39.
the exploration and understanding that we get out of this.
Coming up next, we are going to start configuring the tower, the strong back from the rocket. That happens in a little less than a minute.
It was supposed to.
Just heard,
Once upon
from
a time,
the
Marco,
SMD
but
and
not anymore.
NOM that the spacecraft is verified on internal power, and things are looking good for the Europa Clipper spacecraft.
Can you see it from Jersey? Probably not during the day, Knobbly.
We're also listening to the launch teams as they discuss the data coming in that they're looking at for the rocket.
No, fully expendable mission,
Teams continue
Cubat.
to follow the procedure, as I said, and
A
work,
stark contrast
the,
to
loading of
yesterday.
propellant, finishing up the topping of the three boosters and the second stage. As we mentioned earlier, the three boosters are expendable fully. They will not be coming back for range today. SpaceX is getting the team ready.
Nobody is on board.
To launch this vehicle.
Somebody
today.
was on board on this mission, Knobbly. They
And
ain't
just
coming
heard the
back.
call out that the strong
This is going to
back
take 5 years to get out to
retracting.
Jupiter.
That strong back appears to have retracted.
Who's balancing the audio on this stream? Can I promptly kick them in the face? Like, because that's what you want to hear. You know, like,
Second stage.
NY LOX load is complete.
okay.
Yes, we just got completion of LOX load for
An auto balancer?
the Y booster.
It's
We're
like,
looking for
it's a
now the
stream
center
that has like
core.
3 audio sources. 3.
And the plus Y.
Oh no, we need an auto balancer for that.
NLM, it's the LD on the
PY
count.net
LOX
with
load
the final
What the
status.
heck's going on here?
Yes, LD, this is NLM on Countdown 1, NASA Spacecraft, and the NASA team is go for launch pending resolution of the anomaly.
Oh.
Copy. Go pending outbrief of the issue being discussed on the
Second
anomaly
stage
net.
temperature anomaly. Yeah.
Okay, Tim, so they've mentioned that they're working an anomaly. Tell me a little bit about it.
Yeah, so as we mentioned, they're monitoring some temperatures on the second stage, and things are the teams continue
Don't
to look
do
at that
this.
as they continue filling second stage with liquid oxygen. They're continuing to look at that and monitor
Center
that
core, LOX load
as
is
far
complete.
as they can into the count. So things are continuing to progress forward with LOX load. Center core is just finished up, so all 3 boosters are filled with LOX and RP1.
Yeah, will do
Second
for it.
stage has RP1 on, and we're getting near completion of stage 2 LOX load as the team continues to look at that temperature in the second stage. But we did hear
What's going
NASA
on,
Launch
YouTube
Manager
chat? How you
Tim
doing?
Dunn tell Charlie Myers,
Stage 2
SpaceX
LOX
Launch
load is
Director,
complete.
that they are
45
go
second
for
window,
launch pending the resolution of this temperature issue. So the team has continued to work that, and the team will continue to progress forward in their procedure.
And so these discussions are happening very quickly as we are counting down now inside the final 2 minutes until liftoff.
Absolutely, and we just heard that stage 2 LOX load was complete, and the team is working that. And as you said,
Here's the vent.
this is what they do in the last few moments before launch. They're working their procedures, following their processes, and having these discussions. But we are still progressing forward towards a T0 of 12:06, and things are progressing forward for the launch this morning, or this afternoon.
We are now 90 seconds until liftoff. Weather is 95% go. These boosters on the
I don't know,
outside,
Tessa.
they have flown before the Psyche mission. A little more than a year ago.
Machina.
They are back on the pad along with a brand
Welcome
new
to
center
Mission
core
Control. You go
booster
with throttle up. All right, here we go,
and a
guys.
spacecraft bound for the Jupiter moon Europa.
Yeah,
Minus
Daryl, I
60
can confirm,
seconds.
listening
Falcon
to the
Heavy is in
teams, that
startup.
everybody is go for launch. They have resolved the temperature issue they were looking at on second stage. Everybody's given the go for that, and Falcon is
lot
in
more
startup,
go.
so the flight computer has taken over, and we're getting ready for the
SpaceX Launch
final go.
Director is go for launch.
And there we hear Charlie Myers say that SpaceX is ready for
40.
launch, and Europa Clipper getting ready to lift off.
And there's a great update as now it vents out the LOX
this is space.
inside the
I'm in
line
space.
of the transporter erector. We are
Simba.
inside of 30
30
seconds.
seconds and counting.
It's the 5er. Minus 20 seconds. Guys, I'm gonna turn this down in case
Minus
NASA
15 seconds and
blows
counting.
our ears out.
And here we go. 10, 9, 8, 7, 6, 5.
Sound suppressor is
4,
activated.
3, 2,
Ignition.
1. Ignition. And liftoff. Liftoff of Falcon Heavy with Europa Clipper.
Everything looks good there.
Unveiling the mysteries of an enormous ocean lurking beneath the icy crust of Jupiter's moon, Europa.
Boosters of ignition.
are nominal.
See that the chamber pressures are nominal as we hear. All 27 Merlin engines look great.
Rocket beginning to roll.
Look at that thing.
Putting down 5.1 million pounds of thrust.
30 seconds in. Everything looks good here.
Coming up, they're going to back off those engines just a bit.
Should get a call for power and telemetry here.
So we get ready to head into max
Power and
Q.
telemetry nominal.
Okay.
We hear that power and telemetry on the vehicle are good there. Everything's looking really
Falcon
well.
Heavy is supersonic.
They have reduced power in the center core to get through max Q, maximum dynamic pressure on the launch vehicle as we approach that. The 2 side boosters at full throttle.
A beautiful shot there. Is our camera team?
Yeah, Hooky, pretty much.
Max Q.
Maximum dynamic
Locking
pressure.
into the rocket on a clear blue sky. The view from the booster cam, back down on Earth.
And there we heard the call for max Q. The vehicle is passing through maximum dynamic pressure. Next thing up in about 2 minutes will be booster engine cutoff, where we see the 2 side booster engines, all 18, shut down and get ready for booster separation. But the vehicle is performing very well. Looking at all the telemetry that we have, power and trajectory are nominal.
We've been flying for just under 2 minutes so far. Everything looking good. B-side boosters, once they do their job, they will be expended.
2 minutes in.
If you're familiar with the Falcon Heavy, you know
looks
that
good.
they bring the boosters back on certain launches, but not on this one, because all of the performance is needed to push Europa Clipper into its proper orbit.
To some keep it classy, dude, but I kind of agree.
Things continue to look good as the
Right?
vehicle heads down its ascent phase here.
Guys, NASA's making it really hard to
All telemetry is looking
put
very
any
nominal
useful
for this flight
commentary
this
into
morning.
this. They're not giving us
Falcon
any
Heavy's
numbers. They just
performing very
have
well.
dots. Like we don't have the velocity. We don't have nothing like that. So I'm just like,
Now,
oh
just
yeah,
about
it looks
30
great.
seconds away from separating those side boosters. Their engines will cut off first, then they will separate.
Yeah, fully.
MVAC is chilling.
Okay.
Starting to chill down that MVAC-D engine in the second stage.
And that's where we need to get the engine chilled to the proper temperatures before flowing liquid oxygen and RP1 into it. So they're conditioning the engine to make sure things are ready for when it's ready to start
Thank you
up.
very much.
Stand by for booster separation.
Booster engine cutoff. Side booster separation confirmed.
Yeah, baby.
And there they go.
Those 2 boosters previously flown on Psyche. This will be their 6th flight. We thank you for their service this morning. They did a great job of getting Falcon Heavy and Europa Clipper on its way as the center core takes over and continues mission down its ascent. Things are looking really good in the telemetry. Power and trajectory look nominal, and chamber pressures on the 9 center core engines look really good.
And just a little more, 20 seconds from now, we'll get the cutoff of the main engine on the center core booster that remains.
Even with all the power expending all 3 boosters, it's still going to take 5 years and a gravity assist to get out to Jupiter and Europa.
Flying out over the Atlantic Ocean.
Just shows you the scale that you need to go if you really want to go beyond the asteroid belt.
Inside.
Like, you need a big freaking rocket to do that.
Stage separation confirmed.
Here we go for stage
separation from the center core.
Upper
getting
stage
ready
ignition.
for MVAC startup, SES-1.
Beautiful.
We're getting some applause here in the Mission Directors Center, and there you see the MVAC-D engine lighting up.
Next thing up in about 10 seconds will be fairing separation.
NYPY FTS has saved.
Could they do it faster if they
the fairing
use
has
super
protected
heavy
Europa
Starship?
Clipper on its ascent up into space, but once we get into space, we
This is
don't
the
need
satellite
that fairing
right
anymore.
here. There goes the
Fairing
fairings.
separation confirmed.
Fairing has separated, and those will be recovered, Daryl, by SpaceX's own recovery ship, Go Cosmos.
And there you see them falling away into space. That is the only part of this rocket that will be recovered.
Go at throttle up.
The glow of the MVAC-D engine as it performs its first burn here.
MVAC-D.
This is about a 3-minute and 47-second burn. Things are looking great. Matter of fact, this is one of the shortest first burns that has been done on a Falcon Heavy by SpaceX, but it is required to get us into that parking orbit for that long coast that we have to get ready
They're
for the
recovering those
interplanetary
fairings. They don't
trajectory
catch them,
that
Jack.
we're going to need to get Europa Clipper on its way that we heard Jenny.
They actually they waterproofed the fairings and they just let them splash down. Yeah, they waterproofed them and they just fish them out of the water.
longer first burn and the shorter second burn, but in this case, it is reversed as we look at some crystal clear views.
How amazing was the SpaceX capture? Not going to lie, I shed a tear, was so overwhelmed, and your reaction was everything. I can see how much it meant to you.
Yeah, it was pretty cool.
Is shining both on the spacecraft,
it was pretty
the
cool,
second
Briggs.
Stage, and
Not
on
gonna lie.
planet Earth.
Center core
It is
FPS
beautiful.
has saved.
There we've heard that the flight termination system on the center core has been saved as it heads back to splashdown. Things are looking good. I can tell you, Daryl, we had a beautiful weather day for launch, and as we're looking at MVAC flying in space with the Europa Clipper, it is such a gorgeous view
You guys know
with
my buddy
Earth
Jim?
behind it,
Streams on
and
Twitch.
so we could not have had a better day for a mission launch today.
No doubt about it, Mick. It was simply gorgeous. We had a hurricane.
You're getting
a
some
week
solid
ago,
oxygen buildup on
but
the
after
on
that
the rim
pushed
of
out,
the
it brought us in its wake
of the
near
gas
perfect
generator
weather for launch.
recirculation. It's
And now we're into space.
That's normal.
Dealing with the harsh conditions up there.
Stage 2 FTS is saved.
Stage 2 has made its way into space far enough away for us to be able to safe the flight termination system from a safety perspective. We're about a minute away from second stage engine cutoff as we'll see the MVAC-D shut down and get ready for a long coast.
Crew 8 should be coming
getting
back.
Europa Clipper into that parking orbit
weather
and on its way for the next firing that we will have, the second stage, number 2, to get it into that interplanetary transfer orbit that we need to get Europa Clipper started. So things looking very well this morning. We're about 30 seconds from that stage engine cutoff, which we refer to as SECO 1.
That's right. We'll get into that. Get into that coast phase. These views brought to you, of course, by ground stations across the track that are pulling in the high-resolution data from the cameras. Burn looking good, just a few seconds away from cutting off from that first burn.
What? Everything looked good quarantine, but
the first burn is complete.
Yep, things look really well on the stage burn result. Apogee, perigee, and everything for the mission looks really good. Engine
we
performance,
wouldn't know. We don't have the
very,
telemetry in front of us.
Well,
because we have
performance
dots.
by the second stage for this first
No,
burn.
I'm not letting that go.
And things continue to look good as we head into this long coast for this parking orbit.
The ice mice are back. That's right, Mark.
It's a long coast, so we'll hit that second burn.
This is Kerbal. I'm telling my kids this is Kerbal 3.
Long. This one was roughly 3 minutes and 9 seconds.
We need Jamie. That's right.
Mick, you saw the data.
Right. Where's Jamie? Jamie, help!
Help us! Hearing confirmation that we have nominal orbital insertion as we were looking at the telemetry here, Daryl. That things looked very good. Stage 1 and Stage 2 performed very well on that Ascent flight. And we'll continue to follow Stage 2 to get ready for that second burn. And then, of course, what we're really looking forward to, Europa Clipper separation.
It's going to be a beautiful moment. If the pictures are as clear as we've seen so far, we will see it in all of its glorious detail.
Wait, why'd you ask it like that? What do you have kids? Oh, no.
All right.
Wait a minute. wait a minute.
We will continue monitoring
hey, WD-40, thanks for the raid.
The second stage with Europa Clipper.
wait a minute.
We will bring that to you. Of course, any updates that we have, we'll check back in with you in a little bit. But for now, let's send it back to the host desk with Megan and Jenny.
Oh, wow. I mean, if you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw a SpaceX Falcon Heavy rocket soar off the launch pad with the Europa Clipper spacecraft. I thought... I'm surprised you're here and composed, to tell you the truth.
Yeah, you did a good job of keeping me upright watching the launch.
Yeah, how are you feeling? How was it to see that and feel that, too? I mean,
yeah,
that was honestly one of the loudest and most powerful
Pretty sure they would have said something if they
I've
launched it into the wrong orbit.
It was very emotional in a good way, right? Just kind of overwhelming with just the awe of it, and that it's finally going up into space, and just I feel almost at a loss
I
for
do
words.
too have it,
yeah,
for what it's
I
worth.
know. She was like, I am sobbing. She just kept saying, I am sobbing. I am sobbing. I mean, but everybody can understand that, right? I mean, and this is one of my favorite parts of being part of the broadcast, because I do get to watch it with the co-host, and really, this is so much of your life that you're seeing culminate in a rocket launch.
It is. It's a
The
huge,
Clipper's
again,
flying.
it's almost
Don't be
indescribable,
late
just
on
the
Falcon Heavy's
amount of
wobbly
time
plate.
and effort and
To
all the
Europa's
people
ice
involved
it zips
that
and
got us
zags,
to here
hoping
and
for
to
life or
witness
space
that
frogs in
moment
bags.
is just unlike anything I can describe.
And can you believe it? We are still very much at the beginning of this spacecraft's journey. It is headed for Jupiter's icy moon Europa, which scientists believe could be the best chance of finding the ingredients for life outside our planet. It will take the spacecraft 5.5 years to travel the nearly 2 billion miles to Europa. This is a mission developed by NASA's Jet Propulsion Laboratory in California and Johns Hopkins University's Applied Physics Laboratory in Maryland. Now, Jenny, why does the team think that Europa is the best chance of finding those ingredients for life as we know it?
Yeah, on this planet, everywhere we find water, we find life. And so, that we think that there's this massive ocean of water underneath the ice on Europa is just, how could you resist, So we think that Europa has that water. That's one of the key ingredients for life, along with the chemistry and the energy and the time. It's been kind of simmering away for a long time.
Sure.
It's a great place to go explore.
And how exciting would it be, right, if we could verify that there are the makings of life as we know it on Europa. So let's dig into the science that is going to make this possible.
We have several ocean worlds in our solar system. And by exploring Europa, we're getting a taste of what these ocean worlds are like. Europa probably has beneath its icy surface a global ocean of water.
We think there are thermal vents in this vast subsurface ocean. There may be primitive organisms there, similar to the original primitive organisms on Earth from which we all evolved.
I just love Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
Fish. I honestly
There
have no
are
idea.
shockingly few impact
I have
craters.
dots.
So that means something is going on to erase the
I have
craters,
dots.
just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there's plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening.
Dippin' Dots.
Europa
It's the
Clipper
ice
is
cream
orbiting
of the
Jupiter,
future.
and it's performing 49 flybys of Europa.
Each time we make
Thank
a
you, Thomas.
flyby,
47
we turn
minutes, 40
on
seconds for
all of
SES2.
the instruments at once.
Okay, so it's going to
Most
coast
of us
the other
know
side.
about cameras because that's what our eyes see, but there is a whole slew of other instruments on board Europa Clipper that expands our vision.
We have 4 different instruments that we're really using to take images of Europa's surface. We have the visible wavelength, the near-infrared, the far-infrared, and the UV, the ultraviolet.
We're hoping to see evidence of change, new cracks, new surface colors that indicate different materials, maybe have moved around or come up from the subsurface.
We have an instrument that can sniff the very thin atmosphere, the gases, and
mass
determine the
spectrometer.
composition
Cool.
with extreme precision. And we have another instrument that can tell us the
Bruno would kill
composition
me,
of
Hogan.
dust particles.
We have a magnetometer and a plasma instrument that are going to be studying that magnetosphere environment that Europa is sitting in and Jupiter's magnetosphere environment.
Cool.
The magnetic field of Europa, in turn, can tell us about the properties of the ocean. How thick is it, and how salty is it?
And then we have this novel ice penetrating
idea,
radar
big dog.
that will try to get below the ice shell.
Last but not least, we have a gravity experiment using the communication system of the spacecraft. And from that, we can get essentially a map of the gravity field.
We can get the shape, understand what's underneath, maybe even get some information on the depth of the ocean. It's really a sophisticated payload.
Cool.
The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
We don't know if Earth is the only place that life got started, or if it's really common. And a really important way to get at that is to understand, is there life elsewhere in our solar system?
Yeah, I guess not.
And we were proud to host JPL directors here at Kennedy for launch. She's with Tony now, and they both had a spectacular view of launch.
That's right, Megan. What a spectacular sight indeed. And like you mentioned, we have a very special guest with us, JPL Director Lori Leshin. Lori, congratulations first off on what a beautiful launch and now an exciting mission ahead.
What a great day. We're so excited. Thanks to SpaceX for the fabulous ride.
Absolutely. And, you know, Lori, what would you like to say to the teams who have put in so much hard work and dedication, you know, to this mission?
You know, more than 4,000 people across many different organizations have worked on Europa Clipper, and we're so proud of them and so grateful for their hard work, for their families who've supported them, and especially the 150 or so with us from JPL who rode out the hurricane here. Thank you.
Absolutely. And, you know, can you tell us a little bit more about why planetary missions are important in general that we go and study?
Well, you know, it's really about who we are. Even though it's a robot we're sending out into space, it's a very human endeavor to want to explore the unknown, and especially to want to understand where life came from, how we originated, whether there could be other life out there. It's really a fabulous quest, and we're so fortunate to be able to do that through NASA's science program.
Definitely. And, you know, can you tell us a little bit more about the Europa Clipper vault plate and why teams decided to include one?
The vault plate is so wonderful. It builds on a great history. People know about the Voyager Golden Record, which carried messages from Earth into deep space. It's kind of following in that tradition, and to have a special poem written by Ada Limon, the U.S. Poet Laureate, we're over the moon, over Europa, about being able to carry her words with us and to carry 2.6 million names of Earthlings with us as we go explore Europa.
Absolutely, a lot of special mementos on there indeed. You know, now that launch has occurred, what are some of those key milestones that the teams are going to be looking out for on its way, you know, on Europa's way to Jupiter?
Right, so just today we'll be looking about 1 hour out is when we separate from the upper stage of the rocket. 3 or 3.5 hours out is very important because that's when our solar arrays, those giant size of a basketball field or basketball court solar arrays deploy. We need those.
Get to the side of the Europa Clipper.
And then in just 4 months' time, we'll fly by Mars for our first gravity assist.
You got about 30 minutes
to the burn, all the way along on our way to Jupiter.
Absolutely, Lori. Thank you so much for joining us again here today.
How many orbits before
Megan.
insertion? What do you mean?
Thank you to Lori and Tony.
Orbiting around what?
Now I want to bring back
The sun?
Raquel, who's live at NASA JPL in California. I know the team, like here, erupted into cheers when the rocket lifted off. But now, Raquel, they're back at work and looking forward to what's next, right?
That's right. There was lots of cheering over here, but now here is a live look from inside Mission Control. You can see the team is getting ready for Europa Clipper's next milestone. Now, we showed you them gearing up for this moment, and now they wait for acquisition of signal, but there's a lot happening in there that you can't see. That's why I caught up with Mission Manager Tracy Drain.
I'd like to be able to.
So let's take a look at a behind-the-scenes breakdown.
Yeah, that's going to be a tough thing to do, Jacqueline.
About the space
Burn
here
has
in
to be
Mission
just
Control.
right.
Here in Mission Control, you'll see a lot of folks who are paying attention to the configuration of the spacecraft before launch. But our main role is to catch the baby, that's Europa Clipper, so that we're ready to control it once it's well on its way.
And you'll be right up front here with your headset on, talking to everyone in the room. Can you tell us what is going on behind the scenes?
Sure.
I got the peanuts on the desk.
I, as mission manager, am making sure everything's running smoothly here and communicating status to our project manager in Florida. Next to me is the flight director, whose job is to do what their title sounds like, direct or guide the people in the room through the detailed steps of the procedure.
So if the flight director is guiding the room, who in here is talking to the spacecraft?
The primary engineer talking to the spacecraft is the ACE. They're paying attention to the link between the spacecraft and the deep space network on the ground. They actually get to hit the button that sends commands to the spacecraft when we're ready to do that. Behind them is Telecom, who is responsible for all the hardware on board, the radio, making sure that that's working so the spacecraft can communicate to the ground. And there are some other roles too who are ensuring that the data from the spacecraft is coming to this room properly.
No,
the
Nitro, I never do stuff like
and her job is to understand all the things that are supposed to happen before and during launch, so that if things start to go a little sideways, she'll be heavily involved in making sure we understand how to deal with them. Navigation are assessing and understanding the track that the spacecraft is on once it separates from the launch vehicle, so that the antenna on the ground can point to it and track it.
And then this row behind you, they're making sure Europa Clipper is healthy, correct?
That's right. While systems here is ensuring that all of the different parts of the spacecraft work together, the folks back here are paying attention to individual pieces.
Yeah,
Avionics and flight
that's
software are paying attention to the computer and the software that's running on board. Fault protection is ensuring that if something ran on board in response to a problem, we understand what that is. Power is ensuring things like the solar array and the battery are producing enough energy for the spacecraft. Thermal is making sure that everything stays within the right temperature ranges. Propulsion is noting everything that has to do with thrusting on the spacecraft is working. Then guidance, navigation, and control and motion behavior are ensuring the spacecraft is pointed in the right direction and moving the way that it should.
And there's a special role here too, the test bed. Can you tell us a little bit more about that?
Yeah, the test bed is a set of hardware and software components in another room that we have 2 of them set up like a simulation of the spacecraft so that if things go a little bit off kilter, then we can use them to troubleshoot what's going on.
And there's one more thing I'd like to ask you about. There is a tradition here at JPL that involves some snacks. Could you tell us more about this?
That's right. These are the Lucky Peanuts. And as the story goes, back in the 60s, an engineer was handing out peanuts during a launch just to ease the tension in the room. That one went really well. And so now, as our tradition is, we have Lucky Peanuts with every major event. Lucky Peanuts.
Thank you so much, Tracy.
Absolutely. It's my pleasure. Thanks for having me.
Lucky Peanuts. Nice.
As you can see, Tracy is here now, and the entire Europa Clipper team are in high gear. This isn't the only room where the team is hard at work. Let's take a live look at an additional operation
And these
room.
are all the interns.
This is where an overflow of the team is working.
They're all going to notice
during
they're on camera here in a second.
After launch. Megan, back to you.
But none of them are going to
Thank you so much
it
for
because they're
that
nerds.
video and tour, Raquel, because it really was cool to see all the people again that is making this mission possible. And we have even more people for you all to meet. Take a look.
Humans can be pretty smart, and we do discover a lot of great things, but there is still so much that we don't know.
This is like one of the most exciting times to be working in space.
I feel very fortunate and privileged to be supporting this mission.
The Europa Clipper is NASA's flagship mission to explore a moon of Jupiter called Europa. Here's our Europa Clipper spacecraft being built.
How do you build a spacecraft to go visit a world that exists inside of this extreme environment?
What we're looking for is what's underneath the surface.
My name is Valeria Salazar, and I help put together all the hundreds of different components
The
that
only
make
thing
up Europa
they're bringing back
Clipper.
is the fairing Josh.
My name is Jenny Kampmeyer.
My name is Sarah Elizabeth McCandless, and I am an interplanetary navigator.
I'm Deepak Srinivasan, and I work to make sure that we can communicate with the Europa Clipper spacecraft.
And making sure that Europa Clipper makes its way to Jupiter safely.
I work on Europa Clipper, helping science fiction become science reality.
We're going to Europa to determine whether we have favorable conditions for life.
Here on Earth, no matter what environment you're in, wherever there's water, we found life.
We're going to investigate all those ingredients that we think have led to life as a whole.
But to actually do that, a lot of engineering has to happen.
There's no one person that is responsible for getting this spacecraft built, for designing our science campaigns.
I'm helping enable solar system exploration, helping to enable exploration of the universe.
We're doing some really humanity-changing science.
It's a hard journey to get here. It felt like an impossible dream.
For me personally, being an immigrant, I never really imagined that I would have the opportunity to participate in something like this. Just seeing it up here and knowing that it's going to be up in space, it's pretty humbling.
Seeing it from its infancy to actual realized hardware, to get that on its journey to Europa, it's just going to be a wonderful feeling.
It's been very motivating to see that a part of me will go to Jupiter.
I'm contributing this tiny part of something that's going to help us understand better about our universe.
We're going to be exploring literally the frontiers of life.
Who knows what mission today is going to be that inspiration for the next generation.
That's such an honor to be a part of.
Jenny, I love how emotional you get every single time we see some of the members of your team. And what's incredible is, you know, we did meet a lot, but that's still a fraction of the people who work on this mission.
Absolutely, and it's like a fraction of a fraction of a fraction. I mean, we totaled it up recently, and there are thousands of people who have worked on this project over the years, so it's amazing.
Well, and you said some people have been working towards this mission for 25 years, so that is really...
We sacrificed to Falcon Heavy to get a Super Heavy back. The universe remains in balance. Nice. EJ, are those the exact same clothes you were wearing for yesterday's Starship event? If so, rock on. No. No, I got my RS-25 shirt on today. I had my SpaceX Dragon shirt on yesterday. BA, the shirt that I had on yesterday was a shirt that I bought at the Kennedy Space Center Visitor Center in December of 2015. I had it on when the first Falcon 9 landed. I was there. I watched the first Falcon 9 landing, like from SR-401. And then, if you watch Das's video, Das has a video of the first Falcon Heavy landing, and me and him and a couple of other guys are there, and I have the shirt on again. And then yesterday, you watched Stream for Super Heavy. Yep. That's the Dragon shirt, man. That's the lucky shirt. My original SpaceX Dragon shirt. I wear that. I've worn that every time SpaceX attempts the first landing on a new rocket, and it worked every time. So yeah, that's my lucky shirt, dude. Pretty cool, huh? Did you see the shot from South Padre Island? I've spent the last You didn't growl yesterday. Oh, I did. The compressor blew it out. Yeah, no, the compressor blew it out. I went rah! right when it landed. Absolutely, Mishu. Yep. You got to get one of those for Boeing. No, I'm good. You take care of that shirt then. Oh, I do. You have to update your background. Yeah. No. Give me a second. We'll go all the way through telemetry acquisition, guys, and then I'm taking the rest of the day off. So I'm not gonna lie to you. Basically, since yesterday, I've been doing whatever the opposite of doom scrolling is on social media, just looking at different footage from the catch. And I'm not gonna lie to you, it's still cool. I've been kind of watching the same footage from different angles on repeat for like the past 12 hours straight. Scrolling? Yeah, whatever the opposite of doom scrolling is, that's what we're doing. It's still doom scrolling? Is it though? Like, I'm like, oh, look, a different angle. Oh, this is great. You know, like, hope scrolling? No, Chaos. No. No, I'm good. Cal, what's going on, buddy? How are you? Joy scrolling, blessed scrolling. I crank the hog to it. No, I don't work on a farm, dude. You know what I'm saying? Anyway, back to Europa Clipper.
Does a lot of the work for us. We also monitor everything that's being brought into the clean room. Everything is very tightly controlled. It's cleaned before it comes in, and we sample.
I'm doing well. So well, I'm booster 12. Nice.
We're sampling in 3 different directions, and each different direction gets a different face of this wipe. We want to give ourselves the best chance to pick up any bacteria that might be on here.
Yeah. I've really done nothing since yesterday. I'm not going to lie, dude. Oh, that does remind me, dudes. Hold on. We have, I did have Drummer help me out a little bit. And, give me one second. And we have this here. Oh, wait, gotta turn it up a little bit. Hold on. Ready? We have the so we have the sound effect. We have the sound effect, the ineligible, or inaudible screaming. So we have that. They're removing the flight termination system from booster 12 now. Yeah, Hugo, can you believe they set it back down on the OLM, dude? Can you believe that? Oh, jeez. I did a trick. That, all right, mouse. Yeah, that would be good if you moved to the other computer instead of just flashing this thing over there. Here. Yeah, it's the... Reusable flight termination system. That's right. Here, let's tune back into Europa Clipper.
From right here at the Kennedy Space Center.
I really thought they'd need alignment pins for that. Yeah, Spain. Me too. I guess not. And the umbilical's hooked up, so it is aligned, dudes, which is crazy.
We're currently flying over top of, close to, as you can see right there, the southern tip of Africa.
Yeah, Daryl, the telemetry and Ascent coast is picked up by the ground stations across the globe, and we'll be picking up
Use
data
that
here
for over
shortly.
100 subs.
One of the new things that we'll be doing with Falcon Heavy as we get ready to start up Stage 2 for its second burn, we'll be using the NASA TDRS network, the tracking data and relay system, to be able to pick up that start of Stage 2
that's
once
up there,
that
dude.
comes about. So
It's
that's
up
the
there.
first time we'll be using that for Falcon Heavy, and things are looking great.
Don't bless
So
the
we are
rains. It
hearing
might
that we
produce
just
more
got
hurricanes.
AOS from our Cape Town ground station, and we were watching telemetry. It just came back on the screen, so
You
things
just
are
make a
looking
rhyme,
really
Thomas.
good. Data that has just popped up for the
I do,
orbital
Andrew, yeah.
coast looks good from a velocity standpoint and altitude. So
I
this
know there's
mission
a mechanism,
continuing to look
Baron.
good during this coast phase.
Right, we've re-engaged.
But that only
again
has
our
so much
telemetry
movement,
now.
dude.
We can see exactly where the second stage is and the spacecraft. All is good now. And you mentioned I'm going to fly under TDRS when we lose all ground stations.
I've never seen a
So
Falcon
we're
9,
gonna
but I think
use a
Super Heavy
satellite
spoiled
to
it.
keep track.
Discovery,
All
no
right,
throttle
so
up.
we're
Yeah, I
back
believe
online
that.
now, and we'll send it back to Megan and Jenny.
Hang on.
And we told you earlier how the spacecraft's sensitive electronics are in a special vault to protect them from Jupiter's intense radiation belts. This is a piece or a replica of a piece of that vault. And as we said, it has U.S. Poet Laureate Ada Limon's poem engraved on it. But also we wanted to point out this. This is a part of NASA's Message
never
in a
not gonna
Bottle
be
campaign.
funny.
Can you tell us about it?
Yeah, so more than 2.6 million people signed their name onto Ada's poem
So-
and her message out.
I was wondering what this is. That was written. I'll admit I had to look this up. I didn't know what this meant, but Poet Laureate, that's somebody that's appointed by the Library of Congress to write official poetry for the government, which is okay. That's actually kind of cool that the Poet Laureate did that. Like, you know, normally I'm kind of like, it's a poem on a spaceship. Okay, but the Poet Laureate, that wasn't just any person. That was the U.S. Poet Laureate, like the Poet Laureate, which is pretty cool. That's actually super cool. Last, please. You know what? Nah, Tessa. Nah, I'm not going to. You just type it again. Yeah, her name is Ada. Yeah, Ada Limon, which is cool. That's actually super neat. I'll admit that's actually pretty cool. I could get behind putting Shawnee Be Good on more crafts. Yeah. Yeah, right? Yeah, there you go.
Full way to embody this mission, really, in this vault.
It really, yeah, it's really incredible.
That's cool.
Yeah.
Okay, so the Message in a Bottle campaign was just one of several ways you could be involved in this mission. Some of you took part.
Message in a bottle. Whoa. Message in a bottle. Sorry. I'm sorry. All right.
So what a creative imagination.
Kraken
That
girl.
is what folks or this child is hoping to maybe see on Europa, right?
Yes, and
A mermaid?
Wildest dreams. We hope we see things like that.
A narwhal, yeah. Oh, this is really nice too.
Cool. Yeah, look at that. So that's kind of showing our
That's an
our trip
FGB.
out to Europa, and I love that kind of side view of Europa,
Earl?
seeing the ice and the water underneath. That's
Yo,
amazing.
my guy Earl
You know, if
did a
you're home
functional cargo
watching
block
and
over
you're
there. You
saying,
see
"Well,
that?
I want to submit my
You seen
picture,
that?
my masterpiece of Europa Clipper. There's still time, so just take out your phone and scan the QR code now that you see on your screen. The art challenge is
My
open
guy.
until the end of the month.
Did you put your name on it? I never
If
do
you like
that.
to
Connor.
wear your love
No.
for Europa instead, let's take a look at some other photos now.
That's
These
Cygnus.
are
No, that was a
Jupiter
functional
and
cargo
Europa-inspired
block. That was a
fashions,
pretty.
And this was part of NASA's Style Challenge #Runway to Jupiter. They look very happy to be wearing the mission logo.
That's awesome. Those look like, I think, knitted or crocheted sweaters.
Oh,
wow.
This is my Halloween costume.
I can see that.
I'm going to dress up as Jupiter, and you're going to be Europa and just run around me.
That's great. Every 3.5 days, I'll run around you.
Oh, and these nails are pretty too. It's always nice to see, ways that people can bring their excitement for this mission onto fashion or art or anything like that.
Exactly, and connecting kind of their own creativity with science. Speaking
Oh
of
yeah,
and those
yeah.
nails, I feel like,
those
put us
those
to
are mine.
shame.
Look.
Jenny and I
Can you
bonded. We
see?
did some co-host bonding, and we got our nails done as well. You see, they're meant to look like the ocean. So.
That's right, a little watery blue marbling.
Yeah. So I hope you also liked our runway to Jupiter submission for y'all to consider. And if you want to check out some more of those fashions, those Jupiter and Europa-inspired fashions, again, we have another QR code for you now. Trust me, there are so many more.
What, Baron? You didn't get your nails done?
Checking out that really capture Jupiter's swirls, Europa's
didn't get your nails
icy
done?
glam,
Why
and the
not?
exploration of our solar system.
Why not?
All right, and now we're going to go over to JPL. We have another update from Raquel.
That's right, Megan. We're now taking a live look at another part of the Friends and Family event, this time in JPL's Von Karman Auditorium, where we saw lots of cheering during launch, and among those
this kid's getting at those claps right there.
Of Al Kangahuala, the
That's how you
deputy
clap.
mission manager for Europa Clipper. Al is responsible for overseeing how the spacecraft operates, navigates, and stays on course during its mission to Europa, and he joins us now. Thank you so much for joining us, Al. Can you tell us about your role and the next few weeks for Europa Clipper?
Hello, Raquel. Sure, happy to. Along with Tracy Drain, we take turns in early operations.
Yeah, I saw that
shift by
level. I
shift,
saw it.
As you were mentioning, ensuring the health and safety, not just of the flight system, but of the mission operations engineering teams that are making this all happen. Looking ahead past today, we have many activities ahead. We're going to be performing characterizations, deployments, and checkouts of the subsystems and instruments. Some will be required prior to our first trajectory correction maneuver in about 3 weeks.
Do you
We
want
call
to
that
eat
part
a stick
flight
of
system
dynamite?
characterization part 1.
Baron, whatever you
And
do,
then
just make sure you
the
put
vast
some hot
majority of
sauce
the
on
remaining
it. You know what I
checkouts will
mean?
be performed after
It's
that.
very
That'll put us
chewy.
kind of near the end of the calendar year.
You gotta have some
After
kick to
that,
it.
we'll be performing a flyby of Mars on March 1st,
Don't
2025.
mess with dynamite.
Speaking of flybys, Europa Clipper will have flybys of Earth and Mars. So how does that help it reach its final destination, Jupiter?
So we use planetary flybys to perform what you would consider to be like gravity-fueled maneuvers. The slingshot effect you get by flying by a planet or a moon gives us essentially the ability to add energy to the spacecraft trajectory and to put the trajectory in a more optimal direction.
Yeah, it's going to
So to
bounce
get
off
to Jupiter,
Mars.
we'll perform flybys of Mars next year and then one of the Earth in December of 2026 prior to arriving in Jupiter in 2030. Of course, once we're in the Jupiter system, we'll be performing many flybys of Galilean moons. And you can think of every flyby of Europa as not just a scientific opportunity, but an opportunity to tailor and craft the trajectory to set up the ground track for the next flyby.
Come on back
so
now.
Tell us about that. Like once it reaches Jupiter, what will the paths look like?
Oh, that's
So
cool.
after orbit capture, we'll be proceeding with a series of Galilean moon flybys to reduce the size of the orbit, the capture orbit, to one that's more in
That's
resonance
orbital
with
mechanics,
Europa's
baby.
orbit. So about 11
That's
months
cool.
after orbit capture in April of 2030, we'll perform our first Europa flyby in March of 2031. And by around Memorial Day weekend
That's cool.
That same year, we'll be in full swing performing flybys about every
Oberth
3
is
weeks.
very
Thank
happy.
you so much for your time.
Happy Oberth
Megan,
noises.
back to you.
Now, Europa Clipper is carrying 9 science instruments on board, and they all came from all across the country, as you can see on the map on your screen.
Yeah, isn't it amazing? There are just all of these institutions around the country that contributed
man.
instruments
Watch that
to the
game.
payload, and I'm so glad they did.
Again, very much a team effort. So now we want to take some time to walk you through some of those 9 instruments, and we have the first 4 on the desk now.
Yeah.
Walk us through these, Jenny.
Absolutely. So we're going to start over here.
Okay,
so the
this
one,
one?
yep. So that is our ice instrument. It's actually 2 instruments,
Oh,
and
I
it
see
is
another piece?
Yep, that's our wide angle camera, and then the larger piece is the narrow angle
Bro,
camera.
look at those prints,
And these are
though.
basically going to give us those beautiful
Turns out
color,
OU was a
high-resolution
pretender.
photos of Europa.
Cool.
The next one
Wait.
here is eThemis. This is our thermal imager. So this is kind of like
cool.
our pair of night vision goggles. It's going to
Okay.
help us see spots on the surface where the ice might be warmer,
Dude,
where
those
water
are
might be
really
seeping up
good
from
3D
underneath,
prints.
making that ice melt.
Oh, awesome.
Yeah. And then these two instruments, this is MISE and this is Europa
Seriously, though,
UVS.
Tessa,
And these
I'm
are two of our
in the middle of something,
spectroscopy instruments.
man.
So let's talk a little bit about spectroscopy.
This isn't on topic. I'm going to
So
be a little
take this,
upset.
we're gonna do a little demo here.
I
So
love
yeah,
that.
hold that. I'm
Okay.
gonna hold some of these rocks.
Okay.
So before you turn that on,
Okay.
these look like rocks you might just
Regular rocks
yeah
in my
find
backyard.
find on your backyard,
Mhm.
find on a hike. They're white,
Older
they're
style
gray, there may be a little bit
starships.
of brown and black
On
speckles in
top
them.
of the booster,
But
Tessa? I
what
don't know,
happens when
maybe.
you turn on that flashlight and take a look at them again?
Oh, whoa. This one
Yeah.
is bright yellow. This one's bright green. Oh, and this one's like red.
Isn't that amazing?
So what's happening here?
Yeah, so spectroscopy is basically studying how light interacts with objects and how it may tell us a little bit more about what is going on inside of that object. So looking under visual light without the flashlight, it looks one way.
Right.
But when we put UV light on it, like Europa UVS will do, it can help us see what the rocks are made of.
Wow.
And so that's what both MISE and Europa UVS are going to be doing in the infrared and the ultraviolet parts of the light spectrum.
It's really amazing what you guys can do from just imaging. Like, you're not landing, again, this is not a mission that's landing a spacecraft anywhere, but look what you can figure out just by pointing a camera.
Exactly. By
Or
pointing,
light.
pointing a camera and using different wavelengths of light, we can understand what things are actually made of. And that's really incredible.
Wow, I'm really glad you showed this because,
Yeah.
again, it's nice to see the instruments as they are, models here, but like to see the science in front of us immediately. That was really cool. Thank
Yeah.
you for that.
Awesome.
So again, these are just some of the 9 instruments that Europa Clipper has on board. We're going to show you the other 5 after we get back out to Tony, actually. So Tony, the Europa Clipper mission was developed with Johns
Smart
Hopkins
tech.
Applied Physics Laboratory.
That's awesome.
That's right, Megan. And joining us virtually is
Guys gotta
Bobby
change the
Brown,
camera.
head of Johns Hopkins APL
Nope.
Space Exploration
Nope,
Sector.
not the right
head.
camera.
Bobby, can you tell us a little bit about where you are and how you and the teams are feeling at this moment?
Yeah, well, good morning.
There you
yeah,
go.
I'm standing here in the Mission Support Area East, which is one of 2 mission support facilities. One's at JPL, that's the primary one, and then we have a facility here
Bobby!
in Laurel, Maryland as well. And I'm standing here with members of the operations team who have been plugged in all day and are part of this mission.
That's amazing. Congratulations to you and the team. And in your mind, what makes Europa Clipper so unique?
Europa Clipper is among the most special of special missions that we do in planetary science. The science itself is amazing. It's something that's been in work for 15 years. The spacecraft is huge. It's going to a destination that you could really just dream of. You know, think about the moon, but the moon, you know, our Earth's moon, but with twice the volume of water that we have on the Earth. And our spacecraft's going there to explore. It's a very large spacecraft, very heavy spacecraft, and of course soon our magnificent solar arrays are going to deploy. These solar arrays are 100 feet across. So this is the largest, most significant planetary science mission of all time.
That's right. And can you tell us a little bit more about APL's contributions to this mission?
Yeah, well, a mission this unique actually took the best of the folks at the Jet Propulsion Laboratory and at the Applied Physics Laboratory, working and learning together. This mission took the best of all of us to get this done. Here at APL, we've been responsible
Sorry,
for
Nick.
the propulsion module and the communications electronics and
Sorry,
antenna
man.
that are part of that module. The propulsion module is about 10 feet tall. It's about 2/3 of the height of the overall spacecraft. And we've also built, I'd say 2.5, 2 and parts of 1/3 of the science instruments. So the cameras that we were just talking about, those 8 megapixel, both wide angle and near angle cameras that were, when they were designed, had the same resolution as, say, an iPhone 10.
You have
Those
the
were
Jim
designed
stare down
right here at
perfect.
APL. They're going to be able to zoom in on Europa to a
Hang on, I
factor
wanna
of
listen to
5
this.
greater than what we've seen on past missions like Galileo. We also built the PIMS instrument, which is one of 2 instruments that's looking
Come
at
on,
the
get that
magnetic
off the
field
screen.
and the plasma surrounding Europa. It's going to tell us a great deal. Together, they will tell us a great deal about the ocean beneath the icy surface, And then with JPL, we worked on the MISE instrument, which is that spectrometer that you were just talking about in the previous segment.
That is very exciting indeed.
That guy works for Johns Hopkins APL, Applied Physics Laboratory. He's not stupid. Let me put it that way. That's why I wanted to. That's why I was listening. You know that John Krasinski's from like the same town as me. Just saying. Maybe that's just the thing, right? Maybe that's just the thing. So just putting it out there. Yes, there's the Death Star. Oh wait, I mean no, that's the gas spectrographer right there. But
are in the environment.
Maybe that's why we got the Jim stare down.
Yeah, so kind of as we're flying past, particles will be hitting their sensors and we'll be able to tell what they're made of, how fast they're going, and doing that kind of chemical analysis.
Oh, okay.
The three over here that we have photos of, because they're really big, so we can't have
You couldn't
models.
fit them on the desk?
That's right, they wouldn't fit on the desk. The three of these together are going to be able to tell us about the interior structure of Europa. So we'll start on the end with Reason. Reason is our ice-penetrating radar.
Okay.
That's going to help us understand how thick the ice is, places where it may be thinner. And then PIMS and our magnetometer are studying the plasma fields and the magnetic fields. So let's talk a little bit about the magnetic fields because this is a really interesting part of Europa. So let's do a little demo.
Okay.
So I want you to hold this.
All right.
We're going to pretend this is Jupiter.
Right.
And you can see there's kind of a magnet inside with some of these iron filings. So go ahead and give that a quick shake. Oh yeah, shake it up real good, real good. There you go. Awesome.
Okay.
So now it might be hard to see, but you can see that iron is flowing around like the magnetic fields of Jupiter.
Word.
So if you were to just take a rock and move around, you wouldn't really see much, but try it with that.
A magnet.
Yeah, so that one's magnetic.
Whoa, it's attracting all the little metal shavings.
Exactly. So that's basically, we're kind of pretending that this is Europa in this situation. So the way we discovered that there was an ocean underneath the ice is because there was a little bit of a wobble in the magnetic fields. And we were able to infer from that there must be some sort of conductive layer underneath the ice.
I see.
And so if Europa didn't have that conductive layer of ocean, we wouldn't see this kind of interaction with the magnetic fields.
Gotcha.
So our magnetometer instrument that we have on the payload is super, super important.
Awesome. Thank you so much, Jenny.
Yeah.
All right, so we've been following along with the Falcon Heavy second stage as it continues its journey out with Europa Clipper. So let's head back to NASA's Daryl Nail and Mick Waltman for the next operational milestone.
You know what?
Yeah, that's right. We're getting ready to relight the second.
Okay, they're coming up on second stage engine start. You know what I just thought would be a really good idea? We need to find a way to make brain rot STEM content. I don't know how that's going to work, but it could work. We need brain rot STEM content. Because I see what they're trying to do. They're trying to get kids involved. Like, whoa, the magnet works. Like, I see what they're trying to do, but no. It's not mutually exclusive. It's only mutually exclusive if you let it be mutually exclusive.
3 minute and 21 second burn of the second stage. If you're familiar with the amazing views that we have at this point, then you know that we've got the camera on the second stage. However, we are
some telemetry would be great.
Not expecting to see that view for this particular burn, and there's an important reason for that, and that is because we've been on ground stations leading up into this point, but for the duration of this second burn, we are pulling data through the TDRS
Mayor,
network.
you're probably right.
TDRS network, a legacy satellite system in geo orbit that is going to help us out fill in the gaps so we can at least pull down the important telemetry.
There you go, Roger. Right.
Yeah, we're seeing.
There we go.
We're seeing the telemetry coming through, and things are looking good on the telemetry. And, but as you stated, we can't process that video through there from that aspect, and things continue to go for this burn.
Yes, the TDRS system covering 90% of this burn too. TDRS, of course, standing for Tracking Data and Relay Satellite Network. 90% of the burn will be covered by TDRS.
It's in the bottom right.
But it's a much lower data rate.
I have no idea what you're talking
ground
about.
Station. It's roughly on the order of 20 kilobits per second. If you compare that to your home internet connection, it's the pipe is about 5,000 times smaller.
Yeah, we have to choose what data we send. So we want to send the vehicle telemetry so we can see what's happening from a stage 2 velocity and altitude, and bandwidth for video takes up a lot more, so we opt to get the launch vehicle data, and things continue to look good for this burn.
Anyone who has downloaded video onto their phone knows about bandwidth. You got to have a good connection. You got to have a cell phone that's on a wide connection in order to pull
download
down
tons
video.
of videos
So we will
onto
not
my
have
phone.
video for any part of this second burn. Also, the spacecraft team is not getting any of the telemetry being pulled down because
You guys are gonna give me
again,
crap
as you said,
for
there's a
wanting to
high
do brain
priority
rot stem,
on
and you're gonna let that
communications
fly?
about where that rocket
Hey, you guys got
stage
any
is.
games on your
Yeah,
phone?
absolutely. And this burn continues, and we're about 30 seconds away from the end of this burn, and we'll see how things continue to move. But we're watching the telemetry here, Daryl, and you can see that the acceleration of stage 2 and velocity continue to increase as stage 2 is performing its job to get Europa Clipper into its orbit.
They just explained why there's no telemetry, and EJ talked over it. Yep, there's your acquisition of signal right there. No, weather guy, you're getting confused. You're getting confused. Yeah, see, there's your ground station handover. There's the reacquisition of signal. I'm talking about not having dots on the screen. I get why they don't have telemetry because they're in a ground station handover. But also at the same time, where's the orbital numbers? SpaceX has these on every Starlink mission. Why don't we have them here? No. We have dots. You see? Dots. And then the commentators keep talking about getting great telemetry.
To Megan and Jenny.
All right, it's been now about 51 minutes, nearly 52 minutes until since launch. Our coverage is going to take you through separation
Don't get confused.
and
You're getting
getting
confused.
the first possible signal from the Europa Clipper spacecraft. Let's head back over to JPL, where NASA's Raquel is somewhere new to tell us about the Deep Space Network.
Yeah, Megan, this is a wider look at the Space Flight Operations Facility at JPL, where NASA operates the Deep Space Network. This powerful system is able to communicate with spacecraft traveling beyond the moon. And joining us today is Amy Smith, the Deputy Project Manager for the Deep Space Network. Thank you so much for joining us, Amy.
Thank you for having me.
So your team is waiting to hear from Europa Clipper. Can you tell us why the Deep Space Network is so important with establishing communication with spacecraft?
Speed.
Yes, so the Deep Space Network is part of NASA's Space Communication and Navigation Program. And it is the critical link between scientists and mission controllers on the ground and more than 40 missions that are exploring our solar system and beyond today. So the Deep Space Network is made up of 14 very large antennas strategically located around the world. We have a complex here in Southern California, one outside of Madrid, Spain, and another one in Canberra, Australia.
Canberra.
And those are about equidistant around the world, as you can see in this graphic, so that wherever your spacecraft is, when it needs to communicate to Earth, it can see one of our Deep Space Network antennas. So with the Deep Space Network, we can send commands to our spacecraft, we can collect all that amazing science data, and we can even collect navigation data so that the teams know where their spacecraft is.
Yeah, and what is Europa Clipper doing right now, and which location do you expect to establish communication with first?
Yeah, so the radio on the spacecraft will turn on about its separation and start warming up and sending a downlink signal back to Earth. And we have antennas at our Canberra complex, which are set up right now and waiting for that signal.
And then after that, what is your team doing to prepare for signal acquisition?
Okay, be quiet. So these... Yep. Okay. Only showed it for a second. That's actually what the DSN is doing right now. You know what? Here, hold on. You can actually see what the Deep Space Network is communicating with. You can see it in real time. See right here. So you have a couple of different dishes. These are 70 meter dishes right there. So 63, 14, and 43. And you can see what spacecraft they're actually communicating with in pretty much real time. 55 here in Madrid is communicating with OSIRIS-REx. 53 at Madrid is communicating with Parker Solar. 63, the 70 meter, because you need a big antenna to get to Voyager 1, is communicating with, well, Voyager 1. You need the big one because it's a long way away. Goldstone in California, Goldstone 14 is Psyche. And then over here you have the Advanced Composition Explorer right there. This, you can see all kinds of cool information. You can see the azimuth of the dish, elevation off horizon, and you can see what they're communicating with. Once Europa Clipper gets out past TDRS, the Tracking Data and Relay Network, they'll use the DSN. Actually, they might use the DSN right after separation. It could be either one. That should probably... what is this one? Yep, there you go. Canberra 34, Europa Clipper. They're going to intercept it as it flies over Australia here, which should be... It's actually over it right now. You wouldn't know, though.
Success. We want to thank you for keeping us updated and inspiring our students to dream big. Good luck today.
That's just so heartwarming and amazing to hear from them. And I know they're all watching. So, yeah, thank you so much.
Yeah, that's wonderful to get to hear that. Hi, Tiffany. Thank you for that.
Yes, thank you.
And we have one quick one from Instagram. If life is found on Europa, what will be the next steps? What does this mean for future missions? And I'll add on to that. What would life look like possibly?
Yeah, so, again, we're not a life detection mission. We are not really looking for like a biosignature of something that says like
systems. I can't put my finger on it because all the stuff they're saying is right.
Its habitability. Cool. And if we find that this is a place that is habitable, the hopeful next step is that we would send a landed mission, that we could go in the future and actually land on the surface, take samples and all those things.
All right, let's go back to Daryl and Mick right now.
Very much. And
what the hell is going on there? Yeah, I think she was trying to say stop.
Intentional, Mick.
Yeah, for thermal protection, to make sure that Europa Clipper stays cool and gets going and we get that thermal roll that's going on. But everything's looking good, and the initial data we got from Stage 2 performance looked really good.
Dude,
really good and nominal for that second burn.
All right. As a commentator, if you're in a live cast like that, you don't signal over the table. What are you doing? Under the table. Do it down here so no one can see what you're doing. What are you doing? If you need to communicate to your other commentator, you can't say anything under the table. Under the table. Stop. Stop it. See? I'm waving my hand. Don't do this. You communicate under the table. That's what the table is there for. Oh, jeez.
And the picture of Europa Clipper on the front of the Stage 2. Things continue to look good as we see the altitude of Stage 2 continuing to increase during this coast, and the velocity is ramping down into a steady state. Things continue to look very good, getting ready for separation in roughly 5 minutes.
Now we are having that video signal.
Let DOS do it. I'll be camera
basic.
We need NSF in on this.
That thermal roll that can cause signal fluctuations, right, Mick?
They're getting there. It's not the worst we've seen, to be 100% honest with you. I just wish SpaceX would commentate on it.
Great data so far as the vehicle continues to perform well.
We really want to be locked in at T plus 1 hour and 2 minutes and 32 seconds. That's the current time that we have for the separation of the Europa Clipper spacecraft, and that is a big moment, and we want to be able to see that because, as we've seen in some past NASA missions, it really looks impressive to see that spacecraft going off into its destination.
Yeah, and this being the largest planetary spacecraft that we've built, it's just going to be very cool to see this separation and go. And we heard Jenny and some of the team talk about it, but it just blows me away, the 30-meter, failing of the solar rays. Wish we could see that and all, but this mission is just so excited, got so many people behind it, and we are just looking forward after this.
So during the Apollo era and during the shuttle era, NASA did have PAOs. They had public affairs officers, but the public affairs officers were providing live commentary, and sometimes that was with newscasters. Like sometimes but the PAO would, in the past, would basically just say what NASA's doing. They'd be commentating on the ground loops, right? That's, guys, when I'm doing professional casts, right? When I'm doing that, that's what I do. I repeat and I talk about what you're hearing on the loops, and try to explain what they're saying, etc., etc. It's really hard to do that with dots. I'll be honest with you. It's really hard for me to do anything with this. They're not really giving me anything here. But whenever I do this, I try to work like the old school NASA PAOs. That's always been modus operandi for me. That's how I work. I try to make it old. I try to go old school because I think that's what people want. This is way better than Blues coverage the other day. Yeah, exactly. There's definitely worse. Does the DSN give us full 360-degree coverage of deep space at all times? Yes, it does. That's why you have triangulation, Jack. The 3 deep space network tracking stations are kind of a third of the way around the circumference of Earth. So it gives you overlap. Yeah. Believe it or not, the convergence distance between the dishes and the way they set this up is the convergence points between the 3 ground tracking stations happens right at TDRS. Believe it or not. So that basically makes it so every spacecraft is covered, no matter where it's going. It'll always be covered by TDRS if you have a blackout, because the blackout's at close range because they're using a parabolic dish, right? So they're using a dish that's shaped like a bowl, right? When you do that, you get a converging signal, right? And you can modulate your power to set the convergence of the signal. I'm not the best at RF, I'll be honest with you, right? But long story short, there's a little bit of a blackout area like in low Earth orbit, and that's what TDRS is there. TDRS is there to fill that area, believe it or not.
Less than 30 seconds away from separation. There you see the Europa spacecraft, those massive solar panels that you were talking about all stacked together. This is a big moment for the program, for NASA, APL, and JPL. Let's watch.
Europa Clipper, separation confirmed.
Yeah, baby.
And there you go. NASA's Europa Clipper probe, embarking on a long-awaited mission to study Jupiter's icy moon,
It'll be
Europa.
back in 2 years.
And what a sight, Mick.
That is absolutely gorgeous, Gerald, to see Europa Clipper on its way. Successful deployment from Stage 2. Falcon Heavy performed very well today. Teams behind us are clapping and enjoying. That is a beautiful picture.
Via the video, we can see that Clipper has successfully separated. Please say goodbye to Clipper on its way to Europa.
Now that voice you heard just there is the Europa Clipper flight director, Pranay Mishra. He's with the mission support team.
Okay, all stations, we are waiting for a sign of initial acquisition. Again, Telecom will confirm when we have carrier lock, and DDM will let us know when they see the first packet down.
You can see the second stage.
So they're looking for a lock with Clipper
just
right here.
Orbital sunrise, fully
Canberra 34
by the sun coming over the Earth. And as you just heard the flight director say, they are now going to be monitoring for an acquisition of signal.
Yeah, one of the first things the craft does after spacecraft separation is turn on its antennas. Obviously, it's on internal power, like it's not being powered by the upper stage. It's kind of in a standby mode until it gets the deployment signal, and once it does, they'll lock in. And once again, the DSN, this is DSN now, Deep Space Network now. You can go right on here and you can see what's communicating with what. So, Canberra in Australia, this is Canberra 34. It is a, I think it's a 30-meter antenna, close range for deep space. That's because it's still close to Earth. They're going to try to lock into its signal here. And you'll see this going on when they got a signal lock.
Yes, there's a broad range of times for which AOS is expected.
Give me 1 second, guys.
Flight GNC. Go. Just wanted to comment from the video that we could see that the sun was on the neg-Y side of the spacecraft. There were very low visible separation rates, and the negative Z-axis was pointed at Earth, so this should be favorable for comp.
Copy, GNC. Thank you.
An acknowledgement from the team that that sunlight could help things out. They're looking to warm up the amplifiers.
Go, Phase.
Sorry, I missed the session IDs for our SA sessions from GDS. Can you or GDS repeat those for me?
We did not call them out on net yet, but there are 5 session IDs that it will cycle through, so just a note. GDS, could you note those session IDs in your cache report, and then folks can go
Nothing
there
is communicating with Voyager 2 right now.
So they got 2 radios there that they are warming up. And once they get warm enough, they'll be able to send a signal transmitting down to the deep space network. And that's where JPL, the team
Once
that
again,
you see
watch
there,
DSN 13
California,
or 34.
is awaiting to receive that signal. Basically a
That's
handshake
Canberra
saying,
34.
hey,
Watch this dish.
I'm
Once
here.
this one starts doing this,
I'm good. The bigger telemetry and the more the data about how it's doing will come down later.
Go.
Did we get confirmation that the alarm file was deployed?
That's affirmative.
Do we have the time at which that deployment was complete?
GDS, do you have a specific time for when that alarm file deployment was complete?
34 is it's a 34 meter. Okay, I have it. So I was
17:05:06.
Systems, you copy that time?
Copy, thank you.
Again, that's Europa Clipper Flight Director Pranay Mishra leading his team.
Does it usually take this long? Shouldn't take much longer.
Also, a partner in this mission is the Applied Physics Laboratory. Their team on console as well.
I see people doing this. We'll see. We'll see. We'll see. I see people. Oh, there we go. There's the signal lock. We got it. See? There it is.
We're continuing to
TSN now
monitor
reports lock. Good. We're good.
the search for a signal.
Watch, these people are going to go bananas here in a second.
And I believe we have it.
Right.
There it is.
Flight, this is... Go, Telecom. Flight, this is Cal. We're seeing the signal on the open loop receiver.
Big.
Copy, Telecom.
And there you have it. Confirmation of signal from
We saw it
the
before they did.
spacecraft, Europa Clipper.
All right. Good. Good, 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 good,
Room
good.
there at the Jet Propulsion Laboratory erupting in applause. These teams have
Not
worked
bad,
a
man.
long time. Oh, you've got some high fives.
Flight, I got data on SSC. Copy, Telecom.
Yeah, Bluegill, that did take a second.
Flight, this is Telecom. Looks like 12 kilosymbols per second as expected.
Good.
Copy, Telecom.
Solid data rate.
We're in lock. Flight, this is Telecom. We're in lock.
Copy, Telecom.
Flight systems.
Go, Systems.
We have telemetry. We received good samples, and our displays are lighting up.
So think about it like this, dude. They gotta hail the craft. So think about it like if you're calling somebody, right? You call someone and it connects, right? You know, they pick up the phone, right? It connects, and then you start talking. The telemetry is starting to talk back and forth. You can get a lock. You could connect the phone call, right? But somebody has to say, "Oh, hello," like that's what we're talking about here. They have to lock in on the signal. They have to connect the call, right? That's why they keep saying telecom, and then they got to start talking with it. So Europa, they're not going to say anything back. The Europa Clipper is going to start beaming telemetry to them. It's going to start talking to them, and they're going to get telemetry from it. That's why they have it. That's why they have a dot called telemetry. It's like if you, if you called like your doctor's office and it gave you an automated response, like it's talking to them, but you have to get connection first.
Thank you, GNC.
It's the noisy bit of using dial-up internet.
Go FP.
Yep.
So the particular condition about both branch failing venting does not trigger a monitor, and we have no indication anything tripped, so it just moved on to priming.
Can hear you, Sammy. Copy.
Is that if both branches fail venting, the behavior moves on to and attempts priming. So if that is successful, we could get into tracks on point like we're seeing here. Depending on the cause of the both branches failing venting, which we'll look for prop to confirm more details on.
Copy activity. Activity as you see signs of the launch behavior continuing, please call it out.
Yes, if we're flight risk activity.
Go ahead.
Being in our tracks on point at this point, we are waiting the hour thermal roll, so we should all be looking for signs of being in the thermal roll right now.
Copy activity.
Yeah, flight GNC, just to confirm it again, we are in the thermal roll right now. And so GNC sees that we have already successfully found the sun, done a slew to sun point, and initiated the Z-axis roll. So good indication that GNC is using the engine successfully.
Copy GNC. Do you have an estimate on the start time of that thermal roll?
We're working that right now. Get that back to you.
Thank you. And activity, when you have the telemetry in step 2-8 or can confirm the telemetry in step 2-8, please let me know.
Flight C.
So what? Oh.
Thing in the thermal roll, do we see any change?
Go ahead, Bauer.
Stand by.
So what you're hearing is that the propulsion...
No, shut up. All right, I'm going to use this long drink can. Sorry, I don't really have anything else. I need a satellite model up in here. So what they're talking about is that they've initiated a thermal roll. So basically the spacecraft is going to use its thrusters to start doing this, right? Also long drink. The reason why you want to do that is because you want to ensure the spacecraft heats evenly. That's really, really important. If you have one side of the craft sitting in the sun all day, right? That side is going to get really, really hot and you can fry equipment. So what you do is you swap it, being on the dark side of the spacecraft or on the light side of the spacecraft by just rolling the thing. That is really, really, really important to make sure that the spacecraft doesn't melt, particularly doesn't melt on one side.
From now, they will begin to cut the thermal.
It's like a barbecue. Like, yeah, if you got a rotisserie, right? You gotta keep the rotisserie going to make sure that the whole thing heats up, or else you're just going to heat up one side. That's super important because there's a lot of sensitive equipment on this thing, like the magnetometer, the spectrometer, all the cameras and stuff. You don't want to fry a lens, right? Or fry the chip on the lens. You know what I mean? And that can happen if you just keep it staring into the sun all day.
Board for this launch.
It's very interesting. It sounded like they were having some problems with thruster outgassing, but it seems to be the GNC guy basically said, no, we don't, but we'll see. We'll see what happens.
We'll wrap it up for us. So we'll send
or we're just going to wrap it
back
up
to the host desk and Megan and Jenny.
Yeah, thank you so much, Daryl and Mick. It was really cool to have you guys in there walking us through all of those milestones. And yes, I can confirm for you, Mick, that there were some happy tears next to me. more tears. So to recap, for those just joining us, the Europa Clipper spacecraft has separated from the Falcon Heavy second stage. It's on its own in space, but the team has confirmed a signal from the spacecraft and is now getting all the data that we were expecting from the spacecraft. How are you feeling in this moment? I know we just said happy tears.
Happy tears. I know seeing the separation and the spacecraft moving away from the second stage is that's the last time that, human eyes will see the spacecraft, right? From now on, it's on its own. And so that's incredible. And getting AOS and then the full telemetry right afterwards, it's, we test these things, but it's amazing to see it happen and confirm. There's a little bit of relief in there.
Yeah. We're going to hear from JPL in just a little bit about what full telemetry is, but explain why that is such a big deal.
Yeah. So it basically allows all of our different subsystem experts to weigh in and say, okay, I'm seeing, my system looks good. My system looks good. I'm checking this.
Yeah,
that looks, that's in the range we expect it to be.
That was
so
super cool.
It allows us
Wish
to really
we just did that
understand
the
full
time.
kind of health of the spacecraft.
And so that's why you were cheering.
Yes.
She was in the room. Yes, all of us in the room were cheering. Again, a huge moment for the Europa Clipper team. And I know so many of you guys out there as part of the team, part of Jenny's team, really share in the relief and excitement. So let's get some more reaction from Mission Control at NASA's JPL in California. Raquel, all the cheering that we saw in that room was super cool to see.
Yeah, Megan, and the cheering hasn't stopped. We just heard some moments ago, and the team is still celebrating. And right now we are joined by Tim Larson, Deputy Project Manager for Europa Clipper. Now, Tim, there's been a tremendous amount of work that went into this moment. Tell me how you and your team are doing.
This is so exciting. This is a culmination of the work of thousands of people representing millions of work hours over the years to design this mission, to design the spacecraft, build it, to test the entire system to make sure this system is now able to do everything it needs to do on the way to Jupiter and once we get there in our orbits around Europa. This is every person here and has contributed to this have all contributed to making history today.
And we have acquisition of signal and telemetry. Can you tell us about that data that you've received?
Yes, that's the data that tells us the spacecraft, the state of the spacecraft. It tells us what equipment is on and off, the temperatures, voltages, currents, software messages that tell us what's going on. So all of that informs the team in the MSA, and they can now start evaluating the state of health of the spacecraft and its readiness to keep going.
And we're celebrating now, but there is still a lot of work ahead. Can you walk us through what the next few weeks look like for Europa Clipper?
Yeah, this is going to be a busy time for the team because now that the spacecraft is flying on its own, we'll go through a series of activities where we check out every bit of equipment on the spacecraft, make sure that every subsystem is working as it's supposed to, and then we'll start a series of activities checking out the instruments on the spacecraft. And we have a couple of key deployments that come up right after that, deploying the boom for the magnetometers and deploying the antennas for the radar instruments. So it's going to be a busy few weeks.
Exciting times ahead. Tim, thank you so much for joining us, and congratulations to you and your team.
Thank you. This is so exciting for the entire team.
And that'll do it here at JPL. Megan, back to you. All right, I'm back here at the Space Coast. We are now joined by Dr. Denton Gibson with NASA's Launch Services Program. Today, he was on console supporting the launch. Another successful mission for you guys.
Yes, it was, and an exciting one. It was a beautiful day to launch a rocket to Europa.
Absolutely.
I mean, weather, we couldn't ask for better weather, so that was amazing. But first of all, I just want to say thank you to the amazing team that we have, the combined NASA, SpaceX, LSP JPL team. It did an amazing job. And this team never stops amazing me. Yeah. I mean, just a couple of days after we had a extremely major hurricane hit, with a lot of teams still without power, we were able to get through this countdown and have this amazing launch. And we couldn't ask for a better team that was working this. And I could just say, and of course, our partners at the Space Force also supported us through this launch. But it was just amazing that we got through this.
Yeah.
Well, and I'll just say, as a member of the Europa Clipper team, we are very grateful for the ride to space. So thank you so much.
Yes. So it was awesome.
Yeah, and specifically, I mean, speaking from the team, the fact that, again, we were talking about this earlier, that NASA and SpaceX were able to bring this together to bring us to launch today. Talk a little bit about that with Denton.
Mm-hmm. Yeah, especially right on the heels of a hurricane. It seems like this was a monumental effort to get to this point.
Yeah, absolutely. Yeah. And, even though many members of our team are still without power.
That's right.
We all work together as a team. We came together to turn the things around quickly. The KSC was able to open and get our teams in to start looking at the spacecraft launch vehicle, working through anything, impacts from the hurricane. Thank God there wasn't many significant impacts, so we were able to work through that. We were able to get the team together to work things and able to get to this point. Mm-hmm. So it was a huge monumental task. This team really came together and got it done.
Mm-hmm. Yeah. Jenny, do you have any questions for Denton? Again, I think you're kind of speechless right now.
I know. I mean, what does it mean for LSP to be part of Europa Clipper's journey?
I mean, the mission itself is amazing.
Yeah.
And to be the team that helped enable the spacecraft to get where it needs to go, to get the science that everybody's looking forward to getting. Right? I mean, I couldn't tell you how excited I am to really get
we like LSP.
Some of the science
LSP is cool.
Discovery
I know people that work there.
So it always means a lot to LSP to be entrusted with such a monumental mission and to get it where it needs to go successfully. So that's always, significant to have us be a part of that. So
incredibly beautiful launch.
Yeah, you guys enable so much science that could really change our outlook on our planet, on our universe. So thank you for that. And because as a little thank you to you, I know you guys love our launch highlights. So why don't we take a look at another launch replay from today's Europa Clipper launch.
And here we go.
And here we
10,
go.
9, 8, 7, 6, 5, 4, 3, 2, 1.
Boosted ignition.
And liftoff. Liftoff of Falcon Heavy with Europa Clipper, unveiling the mysteries of an enormous ocean lurking beneath the icy crust.
You like that logo?
Engine chamber pressures are
I already know what's going on. I got a little rowdy there for a second.
See that the chamber pressures are nominal as we hear. All 27 Merlin engines look great.
Rocket beginning to roll. Putting down 5.1 million pounds of thrust. Coming up, they're going to back off those engines just a bit.
It really is an aesthetic rocket. It looks real nice.
So we get ready to head into max
power and telemetry nominal.
Yeah, jets come. The water jets probably are a little bit delayed for a Falcon Heavy, so they don't spray water on the booster. There's a replay.
They have reduced power in the center core
hey,
to
Pat.
get through max Q, maximum dynamic pressure on the launch vehicle as we approach that. The 2 side boosters at full throttle.
I feel like Jenny couldn't really watch that video because she was going to start breaking down again.
I'll watch it later.
Yeah, it was really cool to see that again, those highlights from today. It really just brought me goosebumps again to be thinking about the science that this launch is enabling. So that's going to wrap it for us here at Kennedy Space Center for this live launch coverage of NASA's Europa Clipper mission. A huge congratulations to everyone involved and a big thank you to everyone who participated in our broadcast, especially Jenny Kampmeyer. Thank you so much.
It's been so fun to be here, and I just love the this is the start of our journey of exploration, scientific discovery, everything we're going to learn from Europa. It's just amazing.
And again, this is huge for astrobiologists around the world, but really all scientific disciplines can really gain something from this.
Absolutely, and it's going to change our understanding of kind of our place in the universe. If this is a world that could support life, what does that say about other solar systems that may also have worlds, like Europa?
So you got to wait 5.5 years, though.
I know.
How do you feel about that?
We got to be patient, but it's going to be worth the wait. I think we'll all be sitting on our hands anxiously waiting to get to Europa, but it's going to be worth it.
And obviously there is work to be done while it's coasting there. One other thing that I wanted to bring up for before we let you all go is, Jenny, talk to us a little bit about your trajectory, how you got here to NASA, because I think that's an inspiring way to maybe end this broadcast.
Yeah, people always ask, how can I work for NASA? How do I get to do what you're doing? There's a lot of different paths. My path was a little bit non-traditional. I started my career as an adult as a musician. I was a classical musician and orchestra librarian for a bunch of years. I went back to school for engineering, and now I'm here at NASA. And it was actually watching a launch that kind of kicked me down that path. So if you're out there and you're thinking, I want to work for NASA one day, just go down the path that you want to go down, and you can get there eventually.
Yeah, and we're so lucky to have you. Thank you so much.
All right.
And if you want to continue to follow along with this mission, just scan the QR
That's
code
pretty cool.
on the bottom of your screen. I promise it's the last one. This one will take you to europa.nasa.gov. Together, we will discover the mysteries of both Europa and our home planet. Have a great day, and go Europa Clipper.
Nice.
T-minus 10. I've never been more excited about the possibility of discovery.
I've always said that launches are the best outreach. Yep. Yeah, it's weird. Consider we didn't see a lot of that during this cast. Just putting it out there. Launches are the best outreach, dudes. It's true. You can sit there and you can tell people how cool a launch is till you're blue in the face. Or you can just launch something. Gotta launch more things. Somebody's doing that. But anyway, yeah, that was Europa Clipper. That was good. It seemed like there was a little bit of weirdness going with the telemetry lock, but it took a second. But yeah, now they're gonna work on spacecraft commissioning, and then from there, yeah, we gotta grav assist off Mars, grav assist off Earth. That's gonna take about 2 years, and then in early 2030, it should get out to Jupiter. Pretty good stuff. Pretty good stuff. Europa Clippy. That's right. What do they do in between? They'll work on other projects and stuff. Have you ever played Terra Invicta? No. I missed the whole thing. Anyway, guys, I hope you enjoyed the cast here, but I am going to... I need a day. I'm going to take the rest of the day off here, and then tomorrow we'll resume our regular schedule. Tessa, I want to spend some time with my wife, you tone-deaf plonker. Anyway. Yeah, I basically didn't have any weekend time to spend with Bree, and I want to go spend some time with Bree. So, are we back to Satisfactory? Yes. We will play Satisfactory tomorrow, and we have all the reference pictures that we need from the Reach campaign. Yeah, we should be able to do some pretty special stuff. So, thank you very much for watching, everybody. And I will see you guys all tomorrow at noontime. Have a great rest of your day. Enjoy the day off if you're in the U.S. And, yeah, I'll see you then. Thank you very much for watching.